so let's look at work, which is on page 14. Now, work is another one of these words where it's used in our common everyday language and it has a particular meaning in that context, but it has a very specific meaning in science, and the two don't necessarily work harmoniously together. We know there's this relationship between energy and work, because we've already talked about this a few times, where work is equal to the change in energy, and that they both have the units of joules. But now that we're looking at different kinds of energy other than electrical energy, we need to expand on our understanding of work, because for work to be done, we have to have moved something. And so to move something, we have to apply a force. So we apply a force and it moves a certain distance. So work is also equal to that force multiplied by the displacement. Okay, so this is force in newtons multiplied by the displacement, which is in meters. So we can think of it as Newton meters as well. Okay, so for us to do work, we have to have moved something. Now if we think even more about what this means, then there's rules also about motion itself, because force is equal to mass times acceleration, isn't it? So that means for work to be done, we have to have acceleration. Okay, so I've dropped my book on the ground and now I'm going to bend and pick it up. Have I done work?
Yes.
Yes, I have. I have lifted it up from the ground about a metre, say, roughly a metre. What value goes here?
1.
Yeah, so acceleration due to gravity. And then the mass here would be the mass of my book, wouldn't it? Okay? What about now? Now I'm wandering around like I normally do. Am I doing work now?
Yeah.
Depends if you wander around at the same speed.
If I'm walking at, because I'm walking at a constant speed, I'm not doing any work. Okay? Even though this is off the ground, because I'm just moving it, I did work when I lifted it, because acceleration due to gravity is working in the vertical. But as I walk with a constant velocity, I am not doing any work, because I have to have acceleration. Now, we know that force is a vector quantity and acceleration are vector quantities. Mass is scalar, so are work and energy. There's no vector, there's no direction for work and energy. But this sort of idea of moving around like this is a little bit hard to accept, that you're not doing work. But yeah, the object has to move, and it has to have acceleration. So here, again, like, I push as hard as I can. I'm pushing really hard. To say, it could be like your car's broken down and you're pushing really hard and the car's not moving. You aren't doing any work, because it hasn't moved, even though you're trying really hard. Okay, you are applying a force, but you're not doing work, because for work to have been done, we have to have acceleration. So the moment the wall moves, when I push it, or that car that you've been trying to push, the moment it starts to roll, then you've done work, because it's gone from stationary and it must have accelerated.
So when you had the paper and you were just walking around and the paper didn't have like acceleration, how would you give it acceleration? Would you like throw it?
I could throw it. I could start to walk faster. So if I stand here like this, and then I start walking, I must have accelerated. And during that acceleration phase, I've done work. But if I keep walking, like if I didn't start looking at it until I was already walking, and then I just keep walking at a constant pace, then during that period of time, doing no work on
What if as you're walking at constant speed you're doing this?
Well, that's different, yes. So if we've got motion in the vertical, then we're working against gravity.
So do we constantly have work being done vertically?
Only if I climb up on a chair, go down off the chair, if I'm physically moving up and down, then I'll be doing work. It's just like if you compare walking on flat ground to climbing a mountain, there's work involved in climbing the mountain, because you've got to lift your mass against gravity. You've got to keep climbing up. Yeah. So we can do work in the horizontal, but we have to have acceleration. We're always going to be doing work in the vertical plane, because there's always going to be acceleration due to gravity present. Looking at me suspiciously, and like, what is this nonsense?
So instead of trying to push the car and you were trying to lift it, would you be doing work then?
The only time is if it moves. Okay, so if you're pushing the car and it's not moving, you're not doing any work. If you're applying a force, and we know that the force, because of Newton's third law, that the bigger the force you apply, the cars are pushing back with that same force until the force you apply is bigger than the force the car can apply back, and then you'll start to push and the car will start to move.
So back you said if you're climbing a mountain, that's not because you could be climbing at a constant speed.
Yeah. But the
But
only
the
work is going to be
acceleration.
done in the vertical, not the horizontal then.
So always in vertical, because there's always gravity,
Yes.
even if you're going up at constant.
Yes.
But right now, for you standing still, we don't consider that there's vertical, like we're not saying that.
No work at the moment.
It's only if you're moving up and down
Yes.
that there's that vertical,
Yes. So we still need to have displacement. Okay, so this is a requirement that there's been movement. We've gone from a location to a different location. Now, as it turns out, and this might even freak you out even more, it doesn't even matter how you get there. So, for example, just say I went up something like the equivalent of Jacob's ladder, or I just managed to jump. There's the same amount of work done, because all we're interested in is our starting position and our finishing position. If they are the same, then the same amount of work will have been done, because these horizontal parts won't make any difference.
So jumping up and then landing on the same spot where you have no displacement, does that mean no work has been done?
Well, no, because if you measured how high you did jump,
Right, okay,
Then-
that's your displacement.
yeah.
Yeah, okay. Yeah.
But then would you do that's your work, and then the work would come back down, or you just do one way?
No, the work is happening. Well, the work is happening in both directions, isn't it?
So you just times the work by 2, or because it's still going to be the same displacement back down. It's going to be the same acceleration.
Let's just we'll talk about potential and kinetic energy after lunch, and I just want you to know what each of these means, and in the context of questions, that we have to have displacement, and we have an object which has mass. We also have to have acceleration. And so, yeah, you're doing work now. That's work. We're always going to have acceleration in the vertical due to gravity, but we have to be careful to make sure any motion that's in the horizontal has acceleration, because if the object is travelling with a constant velocity, then there'll be no work. All right, we'll stop there, and you can go back to working on your questions.